Coming up on this week's episode of TechSNAP, it's a simple thing to do, but thanks to some bad practices, another round of databases have been leaked online and your password may have been exposed. We'll give you the details on several popular sites that had a bad week, plus how the Flame malware impersonated Windows Update to spread its infection, and we've got a whole new batch of your questions and our answers. All that and more on this week's episode of TechSNAP. And welcome to TechSNAP. This is episode 61 of Jupiter Broadcasting's weekly systems network and administration podcast. We recorded this episode live on June 7th, 2012. This episode is brought to you by GoDaddy.com, and I'll tell you more about them as the show goes on. And the live stream is powered by the always present ScaleEngine.com. My name is Chris, and joining us like every single week is our host, the admin, the tech, and the teacher, Alan Jude. Hey there, Alan.
Hey, Chris, everybody. Thanks for watching.
Hey, man. Welcome. 61 episodes in a row. I got to say, this week, perhaps, we were facing our biggest challenge when, like, lightning struck near your place, and we're like, uh-oh, we might have to break our streak this week. But nope, so far, 61 strong. Gotta love it. Huge episode this week. And I know I always say that, but it really is true. When I tweeted it out this morning, I mentioned like LinkedIn, Last.fm. I mean, just several, like so many big names have been hacked this week and had password leaks. So we're going to talk about that. Plus, there's been big updates on the Flame virus, which is extremely interesting. And we have a great roundup and a great Q&A section. So I won't delay us too long, Alan. But before we jump into that, I want to announce that next week and potentially on this week's Linux Action Show, I'm going to make a big announcement for the network. And there's going to be two ways you can find out about it first. The best method, if you're not a regular Linux Action Show live viewer, is to sign up for the Jupiter Signal. That's our monthly newsletter. You can get that over at bit.ly/Jupiter Signal. And I'll try to remember to put a sign-up section in this week's show notes. If you sign up for that, we're going to release it early next week. It'll include the big announcement. I'm also going to make the announcement most likely on the Linux Action Show this week. Very exciting thing in store for next week, so go get that newsletter so that way you're one of the first people to know. That's all I just wanted to mention because I know we got a big show and we got to get rolling, sir. So are you ready to jump into the Flame virus?
Yep.
All right, let's do it. Where do we start?
I guess a little bit of background. The Flame is a spyware also known as Skywiper, and it's a basically a really big piece of malware.
Yeah, like people are pretty impressed with it. It's like 20 megabytes in size, which I guess is unusually large.
It is rather large, yes, and kind of cumbersome at that point even. But that's because it contains a bunch of different libraries and external systems that it needs, and includes an entire SQLite database and a number of other things like that. And it's huge.
Yeah.
And it has a number of different modules that have different functionality. One of the modules is called Gadget, which is a man-in-the-middle functionality that enables it to basically pass crafted update packages to other computers on the same network. So basically, it emulates Windows Update.
So it's providing like the means for a man-in-the-middle attack for Windows Update. So it can sort of, it can, I guess, then get itself installed by flagging components of itself as updates?
Basically. So there's one specific package called WuSetupV that has actually been signed by a code signing certificate trusted by the Microsoft Enforced Licensing Registration Authority certificate.
So there's an issue.
They have some of the malware signed by Microsoft so that it will be installed without the WAC pop-up or any of that stuff. And even if you have the machine locked down so that it only runs trusted programs, because this is signed by a Microsoft code signing certificate, it will be trusted. And with the man-in-the-middle attack, they would actually be able to basically, when a machine that is being possessed with the man-in-the-middle would actually go to Windows Update, it could basically have fake updates injected into Windows Update.
So the authors of this obviously had that's a pretty significantly good understanding of how the Windows Update system works.
It's not specific to Windows Update, really. And Windows Update is fairly easy.
Is it more of a just get the right signature
basically
and spoof the right DNS
was to get the a certificate, and the way that they did that actually was with a hash collision. So basically, they made a certificate that had the same signature as some actually valid certificate. Now, the reason they were able to do this is because Microsoft still uses MD5 fingerprints on their certificates. Even though, as we talked about after the big SSL compromises early last year, when the baseline requirements for the issuance and management of trusted or publicly trusted certificates came out, they basically set out these guidelines on how certificates should be done. And basically, MD5 has been a no-no since before 2010.
Right, yeah.
Because this has happened before. I forget which certificate it was, but some group of people with a bunch of PlayStation 3s managed to generate a certificate that could sign stuff as if it was one of the root CAs. Because that root CA still used an MD5 certificate.
With a PlayStation 3.
Well, it wasn't with one. It was like
a group.
100 PlayStation 3s working together. Eventually, they were able to construct a certificate that would match this hash signature. Anyway, so basically, this baseline requirements for the issuance and management of publicly trusted certificates says that we should be using SSH 56 or better. However, not all browsers supported it at the time. So the requirement is only SSH 1, but it should...
Not all browsers, like IE6, kind of not all browsers, that kind of thing?
I don't even know if...
They didn't call out names?
Yeah, I don't know if even if IE8 or 9 support it yet.
Okay.
Probably partly because, as far as this goes, Microsoft's still using MD5.
Yeah, right.
And so because of that, SSH 1 is still allowed for backwards compatibility. And, with SSL certificates, it's very hard to upgrade the infrastructure like that. So,
but I guess what my point was, is where the sophistication came in is, again, we see where the attackers knew how to exploit this, and then also knew how to take advantage of the nature of Windows Update in some sense. I mean, these are two disparate things that they were able to combine into an attack vector.
Well, almost all attacks are that, right? Like, most places have what's called defense in depth, where they have more than one layer of security protecting the system. And so that's why you get these things like island hopping and chaining these different vulnerabilities.
Which is
just a single vulnerability that allows you to get in and screw with things.
Which, of course, is a topic that we cover on the show a lot, because we both really realize this is how this works. And Microsoft has issued some sort of update. I didn't get a chance to read it yet. This is they're going to attempt to make changes to the way Windows Update works in the spirit of defense in depth. It was the quote, to try to prevent this kind of thing in the future. The Flame virus is it's pretty. I mean, it's brilliant work, and I've read that it had control servers to control where the infection spread.
The command and control. There was, I think, I read more than 80 command and control servers, specifically to make it harder to shut down.
Right.
But you have a note here that says most of the victims that have been found with this have been running either the 32-bit version of Windows 7, or almost half of them were running Windows XP.
Yeah.
Because apparently the virus does not work on the 64-bit version of Windows 7.
Right, which I marvel
that to do with the requirements for driver signing in 64-bit and the stronger DEP and a few other things. That basically is not specifically to do with 64-bit, but Microsoft just decided that was the break where they could start enabling this stuff and requiring it.
But what's interesting about it is I read a Wired article that tons of links, by the way, for these stories in the show notes. And one of those links is the Wired article where they mentioned that there's no known Windows 7 or XP vulnerability that they took advantage of on the 32-bit. They just know it only worked on 32-bit. But right. So they're led to believe that Flame was taking advantage of a zero-day Windows 7 vulnerability and XP vulnerability that hasn't yet been disclosed, or maybe even found.
Exactly.
So
that's how most of these type of things work.
It's so fascinating to me. It's an amazing economy and everything. Any other thoughts on that one?
It just says that whoever operates the Flame network used fake identities to register a bunch of the domains so that it would be harder to track them down. And they have servers located in Germany, the Netherlands, the UK, Switzerland, Hong Kong, and Turkey.
Wow. I also saw that whoever created it was careful to screw with the dates when they compiled it and things like that. So it looks like all these different components go back all the way to as old as 1994, even though they use code that didn't even they use toolkits that didn't even exist until 2010.
And setting it back that far seems suspicious, just because that is a way to make it stand out. It's like, I don't know, but I don't think my computer has any files from 1994 on it.
Right. Yeah, I thought so too.
It's like you think you would aim for the default dates on most of the files that Windows XP has. Right? When Windows XP gets installed, there's a bunch of these files that all have the exact same date. It seems like that's the date you would aim for.
Yeah. Yeah, because then it would look like it came, and it would look like it came from the factory CD.
Right.
Yeah.
It also says the Flame toolkit does not appear to be written by the same programmers who wrote Stuxnet or Dooku, although it does share some interesting concepts with Stuxnet.
Yeah, I talked about this in Unfilter episode number 3 that came out last week, the kill list. I actually looked more like I looked at the Flame virus for more like how the media was discussing it and kind of took a poke at them. But one of the things that is being propagated is they are calling the Flame virus 20 times more complicated than Stuxnet, and where they're getting that is because it's 20 megabytes. And
Stuxnet was only 1 megabyte.
Yeah, so I don't know if that's a fair comparison.
It means it's 20 times less sophisticated because, that's an awfully large footprint.
Right. Well, it's because it's doing things like, Lua is being used in some places, and these modules and SQLite.
That was the other one, is that some news outlets were drawing random conclusions and relating the Flame malware to Angry Birds because it was also written in Lua.
Yeah. I also I ran a report in this episode of Unfilter, and I talked about how Bloomberg called it the amplification of a virus, and I just was like, are you guys serious? It is although in the sense of what they can accomplish, it is extremely sophisticated in that sense.
For all the hype so far, like the number of confirmed infections is rather low. Like 185 in Iran, 95 in Israel, 32 in the Sudan, and 29 in Syria. Those numbers are incredibly small and seems like it was highly targeted.
Yeah, exactly. And that goes back to it having a control server. Although that did not prevent people who are former clients of mine and friends to contact me and say, did you know that my antivirus provider just sent me this email saying, don't worry, we've updated to protect you from the Flame virus. Or the Flamer. Norton Semantic calls it Flamer. So it's like the antivirus companies are just jumping on this to sort of pump it up. Like they're emailing you, you're protected.
You have to watch for that at the same time, though, because it's also, that thing we talked about with trend jacking, is that you're going to start seeing phishing emails saying, click here to protect yourself from the Flame virus.
Right.
And so, if you're getting a notification, that's fine. But if it asks you to do something, it's probably not legitimate.
Yeah. The interesting story that continues to go on, we'll keep an eye on it. And I think, one of the things that we're still waiting to hear details on is the actual original attack vector. We know that it can be spread by, modules. We know that it is also spreadable via USB thumbstick, but we don't actually know some of the original attack vectors. That took a while to come out with Stuxnet. So I wouldn't be too surprised if it takes a while to come out here. At least the full
reverse engineering this stuff is quite challenging.
So probably a story we'll stay on top of. Any other thoughts on it before we move on?
No, that's about it. There's quite a load of links here in the show notes.
Geez. Yeah. Tons of good stuff in there, including just an introductory article to it and then following updates and things like that.
Yeah, and some more details on how the cryptographic collision works and things like that.
Yeah. All right, Alan. Now, the next story is about a social network that I have been compelled by peer pressure to sign up an account for. I went there, I used a crappy password, and then I've never gone back. But of course, I've used that same crappy password elsewhere, and now it looks like I might be in trouble because LinkedIn had a bit of a bad announcement this week, didn't they?
Yes. So a list of 6.4 million SHA-1 hashes purported to be the passwords from the popular business social networking site LinkedIn were posted on a Russian password cracking forum.
Jeez.
Now, the first thing to note there is, people are saying, well, LinkedIn has like 100 million plus users, so 6.4 million is not that bad.
Oh, yeah, okay.
First thing to notice there is that the list is deduplicated. So any two users with the same password, the password only shows up on this list once.
Okay. Well, we know that happens a lot. We've seen that from other password leaks.
Yes, the most common, the word password is probably on the covers, 100,000 users. And even the passwords that only be used randomly by 5 people are only going to show up once. So this is
right.
This is possibly the entire password set. or at least the entire password set from a certain point in time, right? It may have been compromised backup or something to that effect. So it may be a smaller subset. But, if there's 100 million users and there's only 6.4 million unique passwords between them, that's an interesting stat.
That would be very interesting. I would actually like to know if that's the case. And also, I wouldn't be too surprised. I mean, not to be mean, but as an overall species, that when you speak one, for the English speakers, there's only so many creative passwords we really come up with, and I'm sure there's, it's the same for every language. It's like I have audited passwords of many different companies, and I swear you could almost interchange the password list sometimes. It's unbelievable.
Mm-hmm. Yep. A couple other things. The list didn't include the usernames, so each password isn't tied to a specific account or something. So it's the way they released it, it's not really enough for you to take that, crack a certain account's password, and then log in as that person.
Okay.
And the other thing is that on the list that I managed to download anyway, which I think is the first one that was posted, a large number of the hashes start with a bunch of zeros, either 5 or 6 zeros. And this was done on purpose, it seems, by the attacker, where basically any password they had cracked already, they zeroed out the first couple characters to mark that, so that people could focus on the ones that hadn't been cracked yet.
Go ahead.
There's quite a few of these that are basically already cracked.
So yeah, I've been bit by this. Now, you're a LinkedIn user, right?
Yep.
So LastPass put up a site where you can go and you can type in your password, and I'll put in, and I use my really stupid easy password, and when I here, I better take it off just in case it does show it. Not that I think they would. Yeah, there you go. So it shows right there that my password has been leaked. There's the SHA1 hash of my password, and then in big red they have there. Boom, there you have it. So, I'll put a link to that in the show notes if you want to check your own password.
In the file I downloaded, 2.9 of the 6.4 million passwords hadn't been cracked yet.
Okay.
So over half of the passwords were simple enough that they've already been cracked.
That's mine was, and mine was a very stupid password. It was like,
mine
never LinkedIn.
Was pretty good, but it was on the list.
Oh, really?
Yep. Well, like it was on the, because almost every password was. And my password, I can't say for sure, but I assume no one else is using that password. And so that's further evidence that that list is legitimate. Huh. The other thing they found is that trying a whole different bunch of permutations of the word LinkedIn, and every one of them was on the list, which seems to suggest that the list is actually from LinkedIn, because, people tend to use the name of the site in their password, or as their password, even with some obfuscation, like replacing the L or the I with a 1. And because basically that's one way that they tried to see, is this list actually from LinkedIn? And also there was a bunch of users on like Hacker News and other sites where they were discussing this, where they use like LastPass or something. So they have a really long, really random password, and they SSH hash it, check against the list, it is there. That means this list probably is from LinkedIn.
Yeah, and LinkedIn's put a nice response on their blog. It's about all they've really said. They haven't said a lot, but this just is going to just keep happening, I guess. We can just expect this to...
The main problem here is the fact that they were using plain SHA1 hashes.
Yeah.
This is equivalent to, I think it was Gawker that was using plain MD5. When you use a hash to store a password, that's extremely insecure because hashes are designed to be really fast to calculate.
That's
the whole point. So when you're doing a cryptographic hash that you're going to use for passwords, you normally make it loop a whole bunch of times to make it take longer.
Right.
Specifically to make it take longer. But for example, I was able to download a rainbow table of all the possible SSH1 hashes for every mixed case alphanumeric password. So that's A through Z, uppercase A through Z, and 0 through 9.
Yeah.
Which is covering a fairly significant portion of all possible passwords. So basically a rainbow table of every possible password between 1 and 7 characters. I think the total rainbow table is about 32 gigabytes, or 32 gigabytes for that. And basically to run 10 gigabytes of it, the first of the 3 tables, to run that against that whole list of 6.4 million passwords on my NVIDIA GTX 560 Ti took 220 seconds.
Wow. Okay. So that's
Because,
no problem at all then.
Right. A rainbow table is basically a time memory trade-off. The idea is that normally when you brute force a password, you have to sit there and try every possible password.
Mm-hmm.
And that's that. Now, that works, except for, well, what if I want to try that password again against some other list next month? So with a rainbow table, you basically start writing down the answer to each of these hashes as you crack them.
Mm-hmm.
And then a rainbow table has a way of chaining these together so that you don't have to store every single hash because it would take too long, or it would take even more space.
Mm-hmm.
But basically, it's a way to keep a table of every possible hash and what the value is in a table. And then you just look it up at the table, and basically you're limited by disk I/O rather than, although it still takes just as long to crack the passwords, it's just somebody else has already done the work ahead of time.
Right.
Like you have your video card sit there and chew out and build these rainbow tables.
Mm-hmm. Mm-hmm.
And then you just store them on disk. Now, tables for stronger passwords like 8, 9, 10 characters are massive, right? Like just up to 7 characters is 32 gigabytes. And I think there's ones, the biggest rainbow table I've seen that you could get is about 5 terabytes.
Jeez.
And they're like, if you send us a couple of external hard drives, we'll load it up for you and mail them back. Because you can't really download that. And it would take you forever to generate it locally. But you know, if you had a group of people that wanted to, they could run this on their video cards and generate this massive rainbow table and be able to crack these passwords extremely, extremely fast.
I wonder if, I mean, there's got to be states that would be interested in those kinds of things.
Yep.
Yeah.
And you know, with the big storage now, it's very easy to be able to store a 32 terabyte set of files.
Yeah. Oh boy, especially when they're building bigger and bigger data centers all the time.
Yep.
All right. Well, any other thoughts on the LinkedIn store?
So basically, the rainbow tables get more impractical as the longer the password is.
Yeah.
Because the tables get, you know, unwieldily large.
Right. Starts to become a big data problem.
Salted hashes can't be attacked by rainbow tables because basically you would need a separate rainbow table for each possible salt. Or basically, the salt gets added to the length of the password, making it even longer, right?
Right.
So, you know, even MD5 crypt, the older basic password hashing, has an 8-character salt. But not only that, it loops 100 times. So it's the MD5 hash of the MD5 hash of the 100 times of the password plus the salt.
Damn.
So, you know, that would take a very specialized rainbow table and it would just be overly large.
Yeah.
Someday in the future, it may be practical, but right now it's not.
Right. Just stay tuned, kiddos. I'm sure eventually we'll be able to do that.
So I have a couple of details about how some of the other hashing algorithms works and what LinkedIn should have been doing.
Yeah.
So MD5, which has been the default in FreeBSD and Linux and so on since the 90s,
right,
uses an 8-character salt and loops 100 times. And now that was great then, but now it's actually becoming an issue because that loop of 100 times can be done so quickly now. Mm-hmm. And, you know, there's, and you only have an 8-character salt. So now most modern operating systems like FreeBSD and all the newer Linuxes have support for the SHA-2 algorithm, so SHA-256 and SHA-512. Now in BSD, that uses a 16-character salt.
Hello, this is Chris. Hello, Alan. Would you like a pizza? We have a deal downstairs in Canada. They just call people up and ask them if they want pizza. We'd like to bring you up a pizza. Is that who that was?
Delivery. Huh? It wasn't pizza. It wasn't pizza, but it's the mailman.
Oh yeah. Oh, you getting a package?
Yep.
Right here on air. That's exciting. Do you need to go get it?
Yeah.
You can go get it. Go get it. All right, well, why don't we take a pause right here and say thank you to our sponsor this week, GoDaddy.com, who's been rocking support for TechSNAP for weeks, and they've been introducing some great deals. And this month, it's only good until June 30th. They're offering $1.99 a month for 3 months on the economy hosting. And they normally have a great deal for this stuff, which is perfect if you want to throw up a WordPress blog or a forum or a wiki, something you just want to get up there and get going and see how it does. When you with a price of $1.99 a month, this is the perfect opportunity to jump in and do that. If their economy plan, you get 10 gigs of space, unlimited bandwidth, 100 email accounts, and 10 MySQL accounts, and then it's pretty easy to upgrade from there. And then you start talking, and you get into the things where the bullet points say unlimited, which is always awesome. So GoDaddy.com makes it super easy to go over there and register your domain name and then link it to a host and move all that stuff up. So it's just a matter of click, 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 and you've bought a domain name, you've got your hosting, and WordPress is installed, and it's managing the updates for you. It's a great service. So thank you, GoDaddy. And use our code 199TECH to get that $1.99 hosting. 199TECH to get that. And you can also use our other codes that we have in the show notes to get additional savings. But seriously, you guys, I want you to go out there and use this to get something cool. Maybe it's, I don't know, pictures of Alan. Maybe you've got some great stills of Alan scratching his nose, raising his eyebrows at me for saying pictures of Alan, things like that you want to put up on a blog or a nice photo gallery. Go use that code 199TECH when you check out to get economy hosting for $1.99 for 3 months. And thank you to GoDaddy for supporting this week's episode of TechSNAP. All right, now Cloudflare?
Yeah.
All right, let's talk about Cloudflare. So their CEO came out and made comments about an AT&T voicemail hacking story.
So basically, Cloudflare got hacked quite completely. And
not just a little bit.
It all stemmed back to their voicemail, but basically, like we were talking about the multiple vectors, it was actually 4 separate security breaks all happening in a coordinated fashion that allowed somebody to basically take over all of Cloudflare.
There you go. Jeez.
Yeah, and there's a nice graphic I linked in the show notes.
Oh, okay. I'll go look for that.
Yeah. So basically, Cloudflare is a web-based or cloud-based WAF or web application firewall and a load balancer. So basically, you point your DNS at Cloudflare, and then Cloudflare then proxies requests to your web server.
Right.
And they block attacks like SQL injection and stuff. Now, they detect some based on algorithms or whatever, and then mostly what they're doing is adaptive filtering, where they notice when other sites get attacked, and they notice the patterns of somebody attempting a brute force against a login form or something.
Mm-hmm.
And then they'll basically, when they see that happening on other Cloudflare customers, they'll block it for your site as well. Right? So it's like heuristics. They're basically by being in front of a large number of sites, when they start to see new types of attacks, they can automatically block your site from receiving that attack.
That would take a pretty big footprint to accomplish. But I guess if you get
if you start with like the base rules like mod security and Apache and stuff like that, then you can block a lot of stuff out of the gate as well.
Oh, I just meant, it takes they must have a pretty big presence in order to pull that information from a wide install base like that. And
their site is predicated on the idea, but they only have so many customers. And as they get more, it becomes more useful.
That seems to be like, that would be sort of the golden solution. Am I wrong?
The issue is that it's basically a single point of failure, and you're losing some of the control over your site.
Yeah, definitely but that's a lot of these caching and acceleration services you have to hand over DNS information to and things like that. So that's not all that uncommon.
No. And it's like, honestly, it's something that Scale Engine was looking at getting into because,
that's what I was going to ask. Because
basically, we could include a WAF as part of our process.
Doesn't Jupiter Broadcasting's DNS for...
yours, because we're also your origin. So we're your web host as well.
Mm-hmm.
Whereas with Cloudflare, they sit between the internet and whatever web host you already have.
Yeah, okay.
They don't actually host your site.
Right. Okay.
But in your case, Scale Engine controls your DNS because we're also your host. But a lot of Scale Engine customers don't. They just have a subdomain that they CNAME to us, and we only control that subdomain.
Right. Okay. That would make sense. Yeah. All right. Interesting. This infograph you have here is this? Did they put this out themselves?
Yes, they did that themselves. Basically, because what they claim is that the point of their company is to aggregate this attack data and share it to everybody to help everybody block these attacks.
Yeah.
And so when they were attacked, they decided that they would give out everything they could.
Wow.
And make it helpful for everybody else.
So
basically,
I got to say, I'm pretty impressed.
The attacker found 4 separate security vulnerabilities and basically chained them together in order to take over the account of one single Cloudflare user. Honestly, it seems like they did a lot of work just to get one Cloudflare account. Basically, the way they did it, though, they took over all of Cloudflare, and they could have taken out every account if they wanted to or had time. So basically, the attackers managed to control the entire Cloudflare infrastructure for about 30 minutes.
No kidding.
Yeah. So the first thing the attackers did was exploit weak security at AT&T and managed to redirect the voicemail for the Cloudflare CEO to a mailbox that the attackers had set up for themselves.
Clever.
So then what they did is they took over the CEO's personal Gmail account. Basically what they did is they used the Gmail password reset process, which basically calls the phone number you have on file in your Gmail account and gives you a PIN that you have to enter. And that's how they reset your password.
Of course.
Now, normally that doesn't leave a voicemail message, but the attackers basically made a specially crafted voicemail greeting message that made Google think it was a person answering the phone.
Oh, so Google, if it's like some of their other password reset options, like they'll make you press a tone.
Yeah. And so basically by putting that tone in the recording, it made Google spit out the password into a voicemail.
Love it. You know, it's not even that sophisticated, but it's clever.
Well, yeah, there's no details on how they managed to hijack the guy's AT&T, but, you know, voicemail pins are only 4 digits, right? There's not that many possible combinations.
Right.
And a lot of those systems don't have like a lockout system where, you know, after 10 attempts, your account is locked or something like that.
Oh, the phone system and your legacy security practices.
Yeah. And so basically, by doing that with the redirect and then the Google password reset, in this guy's setup voicemail box, he managed to get the PIN number and finish resetting the CEO's personal Gmail account. So now he has the guy's personal Gmail account. And as you can see in the timeline, there's some back and forth there, right? The guy gets an email from Google telling him that that his password's been reset. And he's like, well, I didn't do that, so I'm going to go and reset the password again.
Right.
Actually, maybe it makes sense to go through that infographic, the timeline.
Okay. All right. I will pull it up here. So, yeah, it starts on just recently.
You do the blue side, I'll do the red side.
Okay. All right. Okay. So you start first then.
Yeah. So as the hacker, they tricked the AT&T's phone system into redirecting Matthew Price, that's the CEO of Cloudflare, cell phone's voicemail to a fraudulent voicemail box. So that was flaw number 1. So then the hacker visits Gmail and initiates the account recovery process for the CEO's personal Gmail account. So the hacker then records the voicemail message to the compromised voicemail box and gets the PIN number and enters that into Google. And then at the same time, or just before that, when he does the password reset, then it's you.
Yeah, it kind of happens around the same time, exactly. Matthew sees a call from, and then gives the phone number, which is a California number that Matthew doesn't recognize, so he lets it go to voicemail.
And that's when it goes to the fake voicemail instead of his real voicemail.
Right.
Then Google's system is tricked by the fraudulent voicemail and leaves the PIN code and allows the attacker to finish the reset. That's flaw 2. Google's thing got tricked by a voicemail.
Wow, and just a minute later, Matthew receives an email to his linked Cloudflare account informing him that his personal Gmail account password has been changed.
Right, so he has 2 accounts. He has his personal Gmail and his Cloudflare Gmail.
Right.
And they're linked together so that one can reset the other.
Yeah.
So he gets an email saying, hey, your Gmail password's been reset. And he's thinking, hey, that's weird.
Yeah.
So anyway, after he gets that email, the attacker logs in to Matthew's Gmail account and immediately adds the attacker's own email address as the account recovery control.
Right. Jeez. These people, huh?
Yep.
So then, so let's see, that leaves me at 11:46, right? So then at 11:46 a.m., Matthew initiates the account recovery process himself and changes his password back.
And then a minute later, the hacker receives the password change notification from Gmail to the address he just put into the Gmail account settings. And he initiates the process again to change the password back yet again.
A minute after that, Matthew and the hacker continue to ping pong for control over the Gmail account, exchanging control 10 times in 15 minutes.
Yep.
Wow. And then these next 2 things go along the same time, so I'll let you read yours.
And then the hacker was able to remove Matthew's mobile phone number and his email address from the authorized account recovery list so that Matthew wouldn't be able to reset his own password anymore.
Smart. Then at the same time, the team at Cloudflare reaches out via phone and email to multiple contacts on Google's security team who begin investigating the situation. Oh, that's nice.
Yeah, that's an option most other people don't have.
Yeah.
Hacker initiates an account recovery process for Matthew's corporate Cloudflare address, which is linked to the compromised Gmail account.
And then just a couple minutes. Wait, 1 minute after that.
A flaw in Google's account recovery system allows the two-factor authentication that Matthew had set up on his Cloudflare corporate account to be bypassed.
Oh, no.
So basically, you need the two factors to log in, but you didn't need the two factors to reset the password.
At 1 minute after that, Matthew receives notice that he has been signed out of his Cloudflare email account. Kind of transparent at the same time, Cloudflare's opt team ping-pong control over Matthew's Cloudflare account as well.
Yeah. Then a couple minutes later, the hacker uses Matthew's admin privileges to change the password on all other admin accounts in their Google Enterprise apps. And then the hacker initiates password reset request for a targeted Cloudflare customer. So the customer that this hacker's been after the whole time, he does a password reset for that guy's account. And that's where flaw number 4 comes in, right? Flaw number 1 was AT&T. Flaw number 2 was the Google PIN via voicemail. Flaw number 3 was Google corporate apps or enterprise apps allowing a password reset without the two-factor authentication. Flaw number 4 is Cloudflare has their admin emails BCC'd on all password resets. Now, that was for debugging so that they could make sure the password resets were working, and ironically, to allow them to look for suspicious password resets. But because the attacker had taken over the administrative email accounts, he didn't have to hack the customer who is after's email account. He did a password reset, and the admin account at Cloudflare got a copy of the password reset email. Right. And so he was able to reset the customer's password and then log into the customer's Cloudflare and start messing around.
Right, and that was at 12:34. Then at 12:37, Cloudflare's ops team suspends Matthew's Cloudflare account and resets all Cloudflare employee email passwords and clears all webmail sessions, which terminates the hacker's access to the email system. Now, that is some swift action there.
Yeah. So they managed to kick the hacker out of their Google apps, but by this time, they're about 3 minutes too late, and he already has access to the account he was after.
Right.
Now, if they hadn't have been so quick, he could have gone after more accounts or maybe every account at Cloudflare.
Very true.
But he only got after the one he was looking for. So then a couple minutes after they kick him out, because he's unable to access Cloudflare's email, he logs into the targeted customer's account and resets the password for that and redirects their site to Twitter.
Nice. And then just shortly after, actually a little bit longer after that, so this is that was at 12:39 p.m. Now this is at 1:18 p.m. Google's email team is able to reset the personal Gmail account, returning control to Matthew. And then at 1:24 p.m., Cloudflare's ops team reverts changes made by the hacker to the targeted customer account, resets all customer login sessions, and begins manually reviewing all customer logs for the affected period and conducting a full system-wide security audit.
Yeah, so the targeted customer's site was redirected to Twitter for almost an hour.
That's a pretty intense period of a couple of hours there, isn't it?
Yeah.
Boy.
But it does show the setbacks to using the cloud for stuff. For example, in this case, they were using the cloud for personal email and corporate email.
Right, right.
If they had their own internal corporate mail system, it might have been easier to prevent someone from gaining access to it. But at the same time, your own internal corporate thing, unless you're a rather large corporation, you probably don't have two-factor authentication, right? You don't have your own app or the physical tokens.
Well, and the other thing you don't have is sort of the relationship that Cloudflare obviously had with Google, where they call up their security ops team and they're like, hey, we're seeing a bunch of weird Gmail account activity over here. Can you guys get on that? Like, I can't just pick up the phone when I'm supporting somebody's Zimbra server and make that phone call. You know, I mean, there's probably some avenue I can go down, but it's not as smooth as a process like that was.
And basically, I think it was a day or two later, Google has fixed the flaw in the Google Enterprise system that allowed the circumvention of the two-factor authentication.
Jeez, I'd like to know more about that.
Yeah. But yeah, so the flaws were the AT&T thing, and then the fact that he was able to trick Google's password reset system into leaving the PIN number in a voicemail by putting that custom the
dial tone or whatever, the custom message in the voicemail.
DMTF tone into the thing. Then there was the flaw that has since been fixed in Google's enterprise app system that allowed the attacker to bypass two-factor authentication to reset the CEO's password. Now, that might have been just because he had the linked Gmail account, but it may be something, they have two factors for login, but they didn't think of it for password reset.
Don't know.
And the last one was that policy at Cloudflare to BCC themselves on all password resets. So that meant that the attacker could compromise just Cloudflare. Whereas if they didn't do that, then the guy wouldn't have been able to compromise somebody else's account. Although basically, from what I read, the attack's been started sometime in May, and the guy's been working at it for a while. But it also seems like he kind of knew exactly what he was doing. Or at least knew enough to know, probably knew the CEO's mobile phone number, his personal Gmail address, the Gmail apps or enterprise apps logins, and a couple of things. But the login for that is just the CEO's email address, which is, I think, listed in the blog post as well.
Sure.
So
there's no. Here's another problem: is the problem with like things like Google hosted accounts and things like that, which Jupiter Broadcasting uses, is that you just have to learn that one system. And then if you know how all the password reset mechanisms work and you understand how that entire system works, then anybody that's using it, you can exploit that knowledge. Whereas if I have my own custom built server, it's going to be unique to my situation. Now, the disadvantages is Google has teams of people constantly working on ways to make Google apps more secure and fix vulnerabilities, where I'm just one person. But I have an inherent security advantage because my one-person setup is custom, unique to just us.
Well, specifically, my email setup, there is no password reset mechanism.
There you go. Yeah. So you could do things like that.
Administrator set passwords, and the password can't be reset.
There you go.
You can set a new one as the administrator, but individual users can't reset their passwords. Now, that's obviously a usability problem, but for our small corporate team, it's not an issue.
Right. Same with Jupiter Broadcasting. We would not really need to have people able to do that either. All right. Well, man, what a big week. Should we move on to the next story?
Yep. One more story.
One more story, and this one's pretty interesting. The author of the MD5 crypt tool, he's come out on his blog post, I think it's his blog, and said, "I no longer consider my own tool to be secure."
Yes. No, he wrote the tool in 1994, 1995.
Yeah. And
it's basically that algorithm we talked about earlier with LinkedIn. It's the MD5 password hashing algorithm. So it uses that 8-character salt of base 64 and then does 100 loops. Now, obviously, when he wrote that in 1994, 95, that was fine. Nowadays, the algorithms have an adjustable number of loops so that they can be extended in the future, right? In a couple of years, you want to turn up that number of loops to make it take the same amount of time on a newer computer. Because right now, 100 loops of MD5 can be done really, really quickly. And he says in his blog post, he's not going to design a new one now that he considers his insecure, because
he's kind of grumpy about it.
Well, he's not a cryptographer. He wrote that thing because everybody was using DES and MD5 was better. But now, with commercial off-the-shelf video cards that can crack MD5 hashes at a rate in excess of 1 million hashes per second, it's basically just as weak as DES was when he replaced it in 1994.
He's kind of got a lot of caps in here, though. You know what I'm saying? That's what I'm saying. He's very serious about it, I guess.
Yes. But he says because he's not a cryptographer, he's not going to write the next thing. Now, a lot of the next things have actually already been written, but he has a bunch of recommendations for that aren't already done.
Oh, yeah?
Some interesting stuff. Specifically, he says that now that the round count should be tweakable and so on, he says that the algorithm should take at least 0.1 seconds or 100 milliseconds to do one password.
Okay.
So that means every time you log in, it would actually take 0.1 seconds to check if your password is right. And, that probably makes sense.
Mm-hmm.
That way, when someone's trying to do a lot of those, it takes a while, right? For example, to make the million guesses, which can be done in 1 second with MD5, a million guesses that take 0.1 seconds each would take 100,000 seconds, which is more than a day. Right? So to guess a million guesses, instead of 1 second, it would take 1 day.
Yeah.
Now, if that's 0.1 seconds per core, and you have 8 cores, then that's less time, but still, it's 10,000 seconds instead of 1 second.
Mm-hmm. Yeah.
And so that's where that adjustable number of rounds comes in, because you set it to whatever.
There you go. Yeah.
0.1 seconds now, but a year from now, faster CPUs, you turn the number of rounds up so it's 0.1 seconds then, and you can just keep doing that.
Mm-hmm. Just keep as CPUs get faster.
Time.
Yeah.
Right. And basically, it's that that time trade-off is. And if you have 100 logins per second and you need it to not use up so much CPU, you can turn it down a little bit. Or if you're paranoid, you can make it take 0.5 seconds to try to validate each login.
That'd be. You could probably feel that. You'd probably be able to feel that. I don't know about that.
Yeah. If you look back to I think it was one of the very first episodes of TechSNAP where I talked about it. When I experimented with it back in when I was teaching my Unix security class, we get up to where it was taking 13 seconds to hash each password.
Yeah.
But also he makes some interesting recommendations. Instead of doing, for example, with the common implementations of SSH 256 and 512, they do right now 5,000 loops or 5,000 rounds for the hash. He's saying instead of doing that, or along with doing that, would be to mix a couple of different algorithms.
Sure.
So, for example, do 1,000 SSH 256s of 1,000 MD5s. That way, if there's a class break against MD5 or SSH 256, it still doesn't compromise the password completely.
See, he does kind of have a hard-on for this stuff. He goes on to the top of that to say he's not a cryptographer and he doesn't get off on this. And then he writes this blog post full of suggestions.
No, he says he doesn't want to get yelled at by people who actually are.
Oh, okay. I understand that. Nobody likes getting yelled at.
Yeah.
Right.
And the other thing he was saying is that each site that is a significant target, like any site with more than 50,000 users, should design and configure a unique algorithm. So maybe, mixing these different algorithms in a certain way or whatever.
That's interesting.
So that when they're writing tools like John the Ripper or Rainbow Crack and so on, that each different site needs a customized version of it.
What do you think about that?
You can't just write one tool that... there's the chance that people will do something that will make it less secure.
Yeah, they'll do it wrong.
But if they're just mixing these standard things together, maybe it'll be okay. So
take your own recipe of existing standards, mix to a custom proportion to taste, and implement. Yeah, so if you're basically mixing, SSA2 and Blowfish to taste, then... now, we've seen John the Ripper now has support for like 20 different ways of doing MD5 and SSA1 hashing. Because, for example, I think it's vBulletin that a lot of forums use. It's literally just the MD5 of the password plus the salt. So you take the MD5 of the password, add the salt to the end of that, and then MD5 that. So you only have 2 rounds in there. And then a different forum software does the same thing, except for they put the salt and then the MD5 of the password and then MD5 that. We have there's another one where they put the salt in twice, once inside the password and once outside the password, and then MD5 it. I have a feeling this story is going to generate some discussion because we have a few people who follow this show who really get into the crypto stuff when you talk about it. So it's always interesting. I've been watching comments and people start little discussions. But basically, if every site uses its own variation, it would help ensure against class breaks where, if they find a flaw in a certain implementation it sounds like a headache to me. It sounds like a headache. That's all. It just it breaks interoperability. Yeah. Okay. That too. There you go. I mean, that's the nice thing about these, MD5 hashes is that it's the same thing used, by Linux, FreeBSD, Cisco. Everybody uses the same thing, so the password can be used. It can be, if you have an NIS system or something, then you can actually have a FreeBSD machine and an Arch machine share a password list. Yeah. Because they're using the same algorithm. Okay, that part I would like a lot. Yes. That part I would like. Now, most modern operating systems like FreeBSD 9 ship with support for a number of different algorithms. In FreeBSD 9, the default is still MD5, but there is support for bcrypt, which is the Blowfish-based hashing algorithm, and SSA256 and SSA512. And then actually Arch Linux and a few other Linuxes now default to using the SSA256 hashes. Whereas in FreeBSD 9, you have to change that to make it do it. But I'm assuming that, especially because of PHK, who's the guy that wrote the version that is in FreeBSD, and basically it's the version that's in everything. The GNU people rewrote it from scratch so they could license it under the GPL instead of the BSD license, but it is still the same implementation. Because it's in everything, I expect that to start to change eventually. There you go. Fascinating. And the blog post is linked in the show notes.
Yeah.
So, all right.
And he has a couple links there, including a story in IEEE magazine that he wrote about, the fact that he wrote the algorithm while sitting on his living room floor watching his kids learn to crawl. And and that, he doesn't actually know if he doesn't know of any problem with it. But if someone reports a problem with the MD5 hashing algorithm to him tomorrow, he can report it to like the FreeBSD security officer and the Red Hat security officer and a bunch of people and like Cisco, and they'll fix their versions.
Right.
But how many people are using it that he doesn't know about?
Right. Well, that's always
using it where they don't know that they're using it.
That's always a problem with anything it's open source or like that.
The Linux one, because in the Linux version they took his name off of it.
Right.
When they rewrote it, it's his implementation, but they didn't use his code. They wrote it themselves so that it would be GPL licensed. It doesn't have his name on it.
I don't think the responsibility lies with him then. It relies with whoever took it and did their own thing, and now they have to go back and...
right, but basically he doesn't propose a solution, but he talks about the problem that open source has with this, that everybody... Because, it's open and it gets iterated many times and,
what it is the end result is open source takes more of an evolutionary thing. Things kind of go off and they kind of diverge when you wish they wouldn't, and then the stronger ones live.
Right, but all the little ones that are still being used somewhere don't necessarily find out that there is this problem upstream.
That is
when they maintain that relationship with the upstream.
In terms of security, that's a big problem.
And his other point was, because this thing was so popular, it kind of broke the diversity thing. Normally, you would expect, if Cisco routers use his algorithm, then other brands of routers maybe use something else, and so they won't have this problem. But the biggest competitor to Cisco, which is using his MD5 crypt algorithm, is Juniper. And the Juniper JunoS is actually based on FreeBSD. So it uses exactly the same algorithm. So even having a different router, like a non-Cisco router, wouldn't protect you from this vulnerability. And, if they did find something and Cisco released an update, how many of the 10 plus million Cisco routers wouldn't get updated?
And this is a complicated issue.
Yes. And so if you go to his blog, he has a bunch of links, and it's interesting reading.
All right, Alan. I think we're all done with the news. What do you say we jump into the TechSNAP feedback? And thanks for sending your emails to techsnap@jupiterbroadcasting.com or using the Contact Us form up at the top of Jupiter Broadcasting. And some of these were even submitted via our Reddit over at links.techsnap.tv. The contact form, though, seems to be the most popular method, and I'm all for it. All right. Well, the first one is just a comment from Project Morris, who's watching live right now. And he wrote in and said he's very frustrated with the way LinkedIn is handling user communication. He said, I would have expected by now to hear something from their CEO in my inbox. This is days now with no comment responses are long gone. And this is not a good way to treat the user community. And
now, they were investigating and they've actually since posted a post about it and say they've emailed the users whose they've forced password sets on.
There you go.
I never got an email. At least not yet.
And I haven't seen an email either, and my password was
on the list. Yeah. So, but then again, if you're sending 6.5 million emails, it might take a little bit for them all to get out.
Yeah. All right. So this next one is a comment on a topic we covered last week when we talked about how you can clone a Windows box, but you might have issues with its SID, the unique security identifier for a Windows machine. And
why you would probably normally, as part of the imaging process, you would change the SID, generate a new random one.
Right. So, not sure on the pronunciation, but Matthias writes in and says, on TechSNAP 60, you briefly talked about Windows SIDs and how you would change them after you clone the machines. Mark Razusevich himself, who's he is one of the original...
Like an epic Microsoft security researcher who wrote all the cool tools and then got hired by Microsoft to write the rest of the cool tools.
Exactly, like sysinternals and a lot of the original SID changers and all that kind of stuff. And he said that he's come to the conclusion that it's a myth, that cloning your SID doesn't really make any difference. And in fact...
It seems that basically Microsoft is come to the conclusion that some people are going to clone the machines and not change the SID, and so we have to make it so the SID will work anyway. The reason we were talking about it, though, was because the SID is supposed to be a globally unique ID, whereas every single computer would have a different one.
Right.
And every single user would have a different one.
And the issue there is developers assume that it is, so they have the software check that SID.
In particular, the RSA security token software uses the SID as its key,
right,
and it locks your key, your token to only work on that one machine. Now, if multiple machines have the same SID, then that token will work on all those machines when it's not supposed to.
Yeah.
So it's not Microsoft's fault that some developer, in this case RSA, assumed the SID would be globally unique when it wasn't necessarily going to be, or that, if the SID was never meant to be used as a token to identify the machine uniquely, but it was being used as it.
And this might not be an issue with Windows 7 and etc., but I've had problems with clone SIDs, specifically when dealing with Samba servers, and having issues with just machines that at the login prompt will all of a sudden just say they can't contact the domain controller.
Well, because I thought the SID was used as the primary key for joining a machine to the domain controller.
It is a key part of the domain relationship, but I have had, by mistake, I've walked into labs where an administrator or I had cloned a machine and copied the SIDs, and they'll work for a while, and then one morning the machines will power on, and one or two of the machines will just say, cannot find domain controller, your domain is not available, you cannot log in. And that's it, depending on your group policy settings. And then the only thing that fixes it is to unjoin from the domain, change the machine name, rejoin the domain, change the SID, whatever you need to do, and then get it back as a new domain member, and then it works.
Yep.
So interesting, though, because I have also read what Matthias wrote in. All right. Here's the next one, Alan. It's from David, and David writes in, I have another idea for local passwords. He says, hey, Chris and Alan, I believe a better solution to Jono's questions from last week about storing user passwords locally would be to do something that OAuth does. Instead of storing the password itself, the application obtains a token from the server using the user email address and password, and then uses a token for the API authentication. The user can then revoke the token should the computer fall into the wrong hands.
That's actually a fairly decent idea. So instead of having your username and password and then checking a box and saving those on your computer, you would, the first time you tried to use the app on your computer, it would take you to the website, and it's like Twitter or whatever, and you'd log in with your username and password, and it would give you a token that your computer would then use permanently or possibly temporarily, depending how you set up OAuth, and save just that token, and then you can revoke that token in the future.
Yeah.
It's not a bad idea, although it depends on how your app is set up, whether it makes sense. But
and if you have network access.
That's how desktop Twitter, well, this is, if you're logging into a remote service, then you're going to have network access anyway.
Oh, yeah, sure.
But, this is how most desktop Twitter clients work. Because Twitter, said Twitter apps are not allowed to ask for your username and password because they would store that in plain text and that would be insecure. So yes, that's a good idea, although it may not work for everything. It's not a bad idea.
There you go.
Or some system like it. It doesn't have to be OAuth. It just has to be some system that will allow you to validate a login using a token like that. A
big show this week, so we kept the feedback segment kind of snappy, but we'd still like to hear from you. So feel free to send us a question. Maybe you have a sysadmin question, something about a network setup, a server setup, or you have a beginner's question that you've never quite understood the background information on. Feel free to email those TechSNAP@JupiterBroadcasting.com. Use the Contact Us form at the top of Jupiter Broadcasting. Or, if you'd like the community to chime in, submit your question over at links.techsnap.tv's. That's the subreddit, and you can have all kinds of different input. In fact, there's been some interesting conversation over there this week regarding the way that the Microsoft certificate was kind of spoofed and how they relied on something with Windows Terminal Services to do that. And there's a good discussion thread in the subreddit this week around that. So, all right, Alan, with the feedback all done, that means it's time for the TechSNAP Roundup. And welcome to the TechSNAP Roundup. Yeah, that's what that crazy music means. Now, the Roundup are stories that didn't quite make it to the top of the show, maybe need some more research or something you want to read on your own, and almost always are exclusively powered by our subreddit over at links.techsnap.tv. All All right, Alan, I'm going to throw the first roundup story at you. Get ready, Last.fm users, because a blog post from Last.fm has indicated that you need to change your password because they may have experienced a password leak. This just happened as we're recording the show, so details are sketchy at this point. We may have more details next week. But if you are a Last.fm user, go over there, log into your account, and change your password.
Yeah, now, there's been a whole streak of these in the last couple of days, and it almost makes me wonder if it's some kind of class break, if all of these sites had some bit of something in common.
I was thinking the same
in their
thing.
Infrastructure, because eHarmony was also had a password leak. And I don't have the details on what kind of hash or whatever they were using, and Last.fm doesn't seem to have any details about theirs yet either. But if they were all SSH1 hashes, that would be more evidence that there's something in common between these sites.
Yeah. Oh, that would be interesting. Hopefully they'll give us the details. And if something interesting comes up, we'll slot it into next week's episode.
Yep.
All right, you want to take the next roundup story, sir?
Yes. There are early reports that VuPen, the company we talked about before, that's the vulnerability testing and penetration, they're basically a French firm that finds and sells zero-day exploits to governments.
Right.
Apparently, they've been hacked into, and as many as 130 different zero-day exploits for different bits of software may have been stolen.
Now, this is all, again, this is broken right before the show went on the air. But this came from the @security errata account, which people are taking as a legit source here. I like in the subreddit, it was tagged with #irony.
Yes.
#irony, Alan. So this would be like the stuff that they're selling for money, like we talked about earlier. So
yes, and they wanted at least $100,000 for each of these.
Yeah,
but in particular, it could mean just a huge rash of new malware and stuff exploiting zero-day exploits in Flash.
Oh yeah.
So the worst one with these Flash ones is there are Flash ads all over the internet.
Oh yeah.
You sign up for an account at an advertising network, and you inject some malicious Flash in there. Nobody knows it. All kinds of legit sites you're visiting may actually end up with malware on them via the ad networks.
Yeah, those ad network users become sort of the carrier. And
and so that's the problem. It's like you don't have to go to some like shady internet site to get some of this malware. If they get in an ad network that doesn't manually check every submission.
Well, do you recall a couple of weeks ago we covered data that showed that porn sites are actually one of the lower attack vectors, and that religious sites and other sites that have advertising on them that is sort of
not just advertising. Those ones where they run outdated versions of WordPress and so on.
Yeah, but those any of the sites like that are more common of an attack vector, which is complete flip from what people actually, I think, stereotypically think malware comes from.
Yeah, malware doesn't necessarily come from going to porn.
Although it can. Trust me. All of the infections I've always had to clean up for clients have always been from porn. So I'm just saying.
Basically, with a zero-day Flash exploit, you can get drive-by infected by ads on legitimate, clean websites.
Clients. All right. Why don't we talk about this Netflix story? Because this is pretty cool.
Yes. So Netflix, basically in response to the problems, the complaints of a lot of ISPs that Netflix is, makes up 12 or 20% of all internet bandwidth in the US, they've basically agreed to this thing called Open Connect.
How cool is this? Yes.
And so basically what it is it's a big custom designed hardware machine based on a super micro server. So actually very similar to my ZFS server that we covered me building.
Yeah.
Except for it's a custom chassis where all the connectors are on the front, even the power.
Yeah.
So they had to have a custom power supply where the fans spin the other way because it's mounted at the front. And a couple things like that. But basically, it's a FreeBSD box running Nginx and a bunch of hard drives.
Like 100 terabytes. Right? Is it something nuts?
I think it's only 30 terabytes.
100 gigabytes? No, it says, it can handle up to. Has more, it can handle more than 100 terabytes of storage, it says in the article.
Yeah.
But it doesn't necessarily mean they all have 100 terabytes.
Yeah, sorry, it was 32 hard drives, which would be...
That's a lot of caching, right? Because they got to cache the video and all that kind of stuff.
Right, so, and they have dual 10 gigabit NICs, which they say can push up to 8 gigabits per second of data.
They've been watching TechSNAP and listening to how you build the scale engine system, and this is...
Actually, they got their inspiration from Backblaze, which I think we've talked about before, where they built custom-built boxes that could hold a lot of storage.
Yeah.
And a couple of other things. But yes, they're using FreeBSD and Nginx, so it is quite similar to the setup that we use at Scale Engine.
Well, that must be in some ways very validating in a sense, because you know that, I mean, somebody like Netflix who's really trying to solve some major data throughput issues is going.
Well, specifically, Netflix has a bunch of CDNs like I think it's level 3 or Limelight and Akamai and so on.
Yeah.
But basically, when you're at some ISP, especially smaller regional ones, someone watching Netflix is going to be soaking up a lot of their internet transit. With this system, if you're an ISP with enough users, and I think enough users is a fairly small number, Netflix will build one of these for you 100 terabyte boxes and ship it to you for free. You install it in your data center at, if you're your ISP, like if you're probably not Comcast because Comcast is being evil, but especially smaller regional ISPs and even bigger ones, Netflix buys this hardware and ships it to you for free. You hook it up on your network and set some time windows for when they will load up the newer movies. They have like a 2-hour window where they're going to use a couple of gigabits of your internet to download movies. So you set that to be your lowest traffic time. And they will manage the boxes remotely. And basically, now your customers that are watching Netflix will be routed to the box inside your own data center.
I would love to know.
Basically, what this does is provides that thing that Comcast has with their Xfinity, right? Where they don't, it doesn't count against your bandwidth cap to watch movies on Xfinity because it's inside Comcast network where they're not paying for internet transit,
right?
For the traffic. Now ISPs would be able to do the same thing for their Netflix viewers.
I would like to know,
that means that a bunch of ISPs can now exempt Netflix traffic from your bandwidth cap, or just avoid shaping it, or just better Netflix performance. That could be huge for Netflix, and it's free for the ISPs.
I wonder how they do this from a licensing standpoint, because that sounds like they're caching the videos at the ISP endpoints, which I believe is against the Netflix agreements they have with the movie industry. I mean, I'm sure they've figured this out somehow, but
controlled boxes still. I
guess if they just consider it part of their storage network.
From what because basically they're renting space from an ISP. It's a free agreement. We'll provide the hardware, and but from my dealings with a couple of different of the movie distribution companies, they tend to send the movies encrypted with GPG.
No.
Yep.
I had no. I mean, I knew like with the Silverlight player they use some sort of Microsoft encryption
that's
system.
the encryption that gets it to the user, but for storage encryption.
Oh.
It was PGP.
Oh, gotcha.
So maybe like if you gain physical access to one of these Netflix boxes, you may find directories full of PGP encrypted movies.
What a bummer. I mean, could you imagine what a score that would be if you could like, look at all this. I got 100 terabytes worth of Netflix movies, and then they're all encrypted.
But they have some really intense support stuff. Like if there's a problem with the box and Netflix can't fix it, they will overnight you a new Netflix box. And normally you would get at least 2 of them and set them up redundantly. And they have, if there's a problem, Netflix will notify you within 15 minutes, and there are some requirements on your side that you respond to them, and so on. But
it's sort of like when a TV station became more popular in a certain region, they would install new transmitters in that area to provide more localized, better coverage. It's
a stronger signal. It's kind of this will allow Netflix basically lower their cost, because all the bandwidth that the ISP is getting for free by using their own internal network and not having to use their internet transit, Netflix is getting all that bandwidth for free as well. So it's great for Netflix, and it helps the ISPs.
No wonder they're paying for the box.
Yeah.
All right, should we move on to the next round of story?
That's how the biggest CDN in the world, Akamai, works. Is they get their boxes installed at ISPs.
Right.
And because Akamai hosts things like Windows Update and eBay
and iTunes.
And so basically Netflix is saying, why pay Akamai because we're Netflix. We're now big enough and have enough clout, especially because Akamai has to be global for all those things like iTunes and Windows Update, but Netflix only really has to be US centric. They have some options in Canada and I think the UK, but that's it.
Well, the other advantage it has is a better end user experience, and then the movie will buffer faster.
Yeah.
So it's a good watching experience too. So it's like this massive win-win.
But I think specifically, it's stopping the ISPs from being mad at Netflix or
Yeah.
not liking Netflix.
Yeah. Yeah. It's definitely, it's providing a problem.
Netflix is providing, is saturating your pipes.
Yeah.
Then you're going to want to shape it and slow it down, and you know, you're going to be mad at Netflix.
Yeah.
Whereas if it's using your internal infrastructure and, you know, you only have to download each movie once to the caching system,
yeah,
you're going to be much happier about it.
Yeah. All right, we should move on. It's supposed to be the roundup, Alan. We're supposed to be moving quickly here. All right, the next to last story on the roundup this week is Firefox 13 is out. It's got its new home screen, but the actual reason I wanted to mention it is because they've included Speedy support, which has been built into Chrome, and this is Google's replacement for HTTP.
Yes, and specifically, they put it in to address the fact that people claim Firefox is slower than Chrome, especially on Google sites, and that's because of the support for Speedy. I think there are not that many sites that use Speedy yet, other than Google stuff and Twitter, mostly because there are not very many web servers that can do Speedy yet. However, Nginx has a developmental version that can do it, and it should be in the next couple of releases. There should be Speedy support for Nginx. And because you can do Nginx as a reverse proxy in front of any other web server, that could mean Speedy for everyone.
Oh, Speedy for all. There you go. All right, last story on the roundup this week. A hacker claims to have access to Mitt Romney's personal Hotmail account. Yep. Side story, Mitt Romney uses Hotmail.
Yeah.
And actually fairly recently, as of like March too, I guess. Did you glean anything that stood out to you in this article?
No, I didn't even have time to read it.
All right. Well, I got the details is that it was essentially your generic password reset. He guessed one of Mitt Romney's secret questions, which was his pet name, which I guess he knew. And
I think there was a whole controversy about strapping a dog to a roof or something.
And I guess he found emails that are semi-embarrassing in there. But yeah, you can read the rest if you want in the show notes. But
that would be interesting. Also, the best thing to do when you hack someone else's Hotmail is to send embarrassing emails to a bunch of their contacts.
Right. The thing he did that disappointed me, though, is that he used his Hotmail account for state business as governor. So, like, he was sitting there emailing people. I just, it's so unprofessional.
Especially when you're given an email address that's official.
Right. Right. But that's on the books. All right. Well, there you go. I think that's the whole show. Yeah, Alan?
Yep.
Man, big week this week. And of course, TechSNAP is live every single Thursday at 1 p.m. Pacific. If you are an Unfilter live streamer, we also do these Thursdays. We do Unfilter Thursdays at 7 p.m. Pacific. However, this week, Unfilter will be live at 11 a.m. on Friday. We moved it to Fridays because one of my co-hosts, Chase, is off at E3. Also, just a quick reminder that when you're over at JupiterBroadcasting.com and you think you might be doing some shopping, say over at Amazon US or Newegg or ThinkGeek or Best Buy, use the affiliate links there to support the network. You help support the production of TechSNAP and the other shows on the Jupiter Broadcasting Network when you use those affiliate links, and you pay my paycheck too. So thank you to everybody who does that. You help keep these shows on the air, quite literally, when you do that. So yeah. All right, Alan. Anything else we should cover?
Nope, that's about it.
All right, well, thank you, sir, for a great show. And thank you to everyone for tuning in to this week's episode of TechSNAP. And we'll see you right back here next week.